Today's topic for review is ratios and proportional relationships. So a lot of what is the constant of proportionality, a lot of proportional ideas today. So here's the first example, example 1. If half a gallon of paint covers 1/6 of a wall, then how much paint is needed for the entire wall? Well, I can think of like 3 different ways you could do this. One of them is to, figure out, okay, well, 1/6 it takes to cover 1/6 of a wall, it would take a half a gallon, right? Well, to cover the entire wall, that's 6/6, right? So I could draw the bar model and say, okay, there's 1/6, 1/6, 1/6, 1/6, and one more of those. Hopefully they're all more equal. We get 6/6. 6/6 equals an entire wall. Well, 1/6 takes half a gallon, that 6 takes half a gallon, that 6 takes half a gallon, that 6 half, and keep going. So I could draw a picture and say, how many halves do I have? 1, 2, 3, 4, 5, 6 halves. 6 halves would make a total of 3 whole gallons. So I could draw it. I could say, well, if half a gallon of paint covers 1/6 of a wall, how much paint will it take to cover one whole wall? Well, to get 1/6 equal to 1, I would have to multiply and do the equivalent fraction way of multiplying by 6, and I would get 6/6, right? 6/6 is 1. So if I multiply my numerator by 6, I would get 6 halves, which is also equal to 3. So I could get 3 gallons that way. Or you could actually do the division of half a gallon divided by 1/6 and do, okay, that means 1/2 times, keep it, change it, flip it. The multiplicative inverse is 6/1, and you could cross cancel and you'd say, oh, that's another way of showing 3 gallons. So 3 different ways you could do it. You could draw the picture, you could set up an equivalent fraction, or you could actually do the division of 1/2 divided by 1/6. That's what's called a complex fraction. So do you understand that to multiply by the same number each time, you could get a proportional relationship showing up in a table, for instance? The table below gives the price for different numbers of books. Do the numbers in the table represent a proportional relationship? So does the proportional relationship y divided by x, does it give me a constant of proportionality? Or am I multiplying by the same number each time? Remember, this would be x and this would be y. So am I multiplying each time by 3, or when I divide my y by my x, okay, 3 divided by 1, that gives me 3. 9 divided by 3, that gives me 3. 12 divided by 3, that gives me 3. 18 divided by 7, that doesn't equal 3, so that doesn't work. So I could do it through the constant of proportionality relationship. Does y divided by x give me a constant? Or is there some number, if I did it as the multiply way, 3 times 3 is 9, 1 times 3 is 3, 4 times 3 is 12, 7 times 3, not 18, that would have to be 21. So that's not correct. So I know that this last value in the table is not constant like the others. So do the numbers in the table represent a proportional relationship? No, not all. They are not all in the ratio. One to 3, or there's not a constant of proportionality. There's no constant of proportionality, that K. There's no K. It's not constant. It's not the same each time. This would have to either be 21 or this would have to be a 6. Then it would be in a proportional relationship. So you have to check all of the values. Don't be fooled by a table and just do like the first 2 or even the first 3, because the fourth one here was the one that didn't work. How does a constant of proportionality look in a graph? Is this a proportional relationship? Well, I remember from graphs that they have to go through the origin. They have to start at the origin, and they have to rise or be a straight line through the origin, rise constantly through the origin. This graph below represents the price of bananas at one store. What is the constant of proportionality? Y divided by X equals that K constant of proportionality. That's the K thing. So the Y's divided by the X's. What's a nice easy point to read? Well, not that one. Not this one, not this one, not this one, but this one does cross exactly through the graph paper nicely. 4 pounds, which is my X, is 100 cents, which is my Y. So my Y divided by my X, 100 divided by 4, it looks like 25 cents a pound. Yeah, that looks like about 25 cents a pound, and that looks like about the number 50, halfway between 40 and 60, and that's probably close to 75. That's exactly, yes, 100 divided by 4, so always pick the point that's easy to read. This looks like, oh, it's about 125, right? And that's about 150. So it does look like it's going up by 25 each time. So the answer is 25 cents per pound. That's the constant of proportionality. K equals 25 cents per pound. If you like using the dollar sign, make sure you use the decimal in the dollar sign, but not the decimal point and the cent sign. $25 or 25 cents per pound. So my constant of proportionality is the rate of 25 cents per pound. That's in a rate. Always make sure you use the exact point here. Use an exact point, not one that you're like, it kind of looks like this. Onto the next page, price of bananas again. The price of bananas at another store can be determined by the equation P for price, where P is the price, equals 35 cents times N, and N is the number of pounds of bananas. What is the constant of proportionality or the unit rate? Well, here, instead of doing Y divided by X equals K, they're solving for what it's in the form Y equals KX. Remember, you could write it either showing the division of the Y divided by X equals K, or its equivalent form. Oh, if I take K and multiply it by X, I'll get Y. So what is the constant of proportionality? Well, my Y is my price. That's my P. And my X is the number of pounds, which is my dependent variable. N is my independent variable. Price, because the price depends on the pounds. So my Y is always my dependent variable, and my X is always my independent variable. The more pounds I buy, the more the price. The price depends on the pounds. So this is in the Y equals KX form. So my constant of proportionality, my unit rate is 35 cents per pound. They've given you the Y equals KX form right here. They wrote it in the equation. P is the Y, equals 35 cents N is your X. What is the constant of proportionality? It's 35 cents a pound to buy those bananas. So sometimes they may ask you to find the constant of proportionality in a table, like this example 1, or in a graph, like example 2, or in an equation, like example 3. So be ready for any one of those constant of proportionality questions. It's been a while since we've done this. A student is making a trail mix. Create a graph to determine if the quantities of nuts and fruit are proportional for each serving size listed in the table. If the quantities are proportional, what is the constant of proportionality or the unit rate that defines this relationship. Ooh, create a graph. What is, if they are proportional, what is the constant of proportionality? And explain how the constant of proportionality was determined and how it relates to both the table and the graph. Well, goodness, we don't have graph paper here. We should have a piece of graph paper. So let's see what we can do. Let's see. How the constant, well, first we have to decide, is it a proportional relationship? So my x, my y divided by my x. So 2 divided by 1, well, that's 2. 4 divided by 2, y divided by x, that's 2. 6 divided by 3, and I'm just taking the table values right here. 6 divided by 3, well, that equals 2. And 8, y divided by x. Remember to do y divided by x. Here's my y. Here's my x. So, and that also equals 2. So yes, this table is showing a constant of proportionality. K is shown in the, right here. Here's where the constant of proportionality is shown in the table. So it says, explain how the constant proportionality is determined and how it relates to the table and the graph. How did I determine it? I did y divided by x to get k. How to determine if it is a proportional relationship. Where do I see it on my table? Well, when they give you x equaling 1, how many people, I hope you remember this. When x equals 1, there it is. X equals 1. So in the table, here's the constant of proportionality. If they give you when x equals 1. Let's see if I can pull a piece of graph paper on here. So I'm going to do when x is 1. So when x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 6. When x is 4, y is 8. When x is 0, do you think y is 0? Yes, it is. Because, yes, it's going up 2, for every 2 cups of fruit, there's 1 cup of nuts. So my x-axis here is the nuts. My y-axis here is the fruit. So when my fruit goes up 2, my nuts goes up 1, the cup of nuts. So when my fruit goes up 2, my cup of nuts goes up 1. So yes, this is a proportional relationship. This looks to me like a straight line through that will graph through the origin. Where do I see how is the constant of proportionality shown in the graph? It's right here. Here's my k when x equals 1. So there's my constant. For every 2 cups of fruit, I have 1 cup of nuts. So that in that trail mix, that is a proportional relationship. So the questions were, if the quantities are proportional, which they are, what is the constant of proportionality? 2, for every 2 cups of fruit, 2 cups of fruit for every 1 cup of nuts. Per 1 cup of nuts. That's your constant of proportionality. So that's my constant of proportionality. Explain how I got it. Well, I used my table and I divided y divided by x to get my k. And how it relates to both the table and the graph. In the table, the constant of proportionality shows up when x equals 1. In the graph, which is right here, and in the, right here, and in the graph, right here, when x equals 1. That's my constant of proportionality. Hopefully you remember that from many months ago. So I'm going to try to move this. Come on, move up. I'm going to move this graph back out of the way now. Oh, isn't that interesting? We won't move that. So I'm going to have to erase this. Oh, come on. Okay, so now I can go on to the next question. Example number 5. The graph below represents the cost of gum packs as a unit rate of $2 for every pack of gum. That's my K. That's my constant of proportionality. The unit rate is represented as $2 a pack. The unit rate, also called the constant of proportionality, represent the relationship using a table and an equation. They gave me the graph. So the table would be X is the number of packs, right? And my Y would be my, or you could do it horizontally or vertically. I'm doing it vertically. So I do see that for when X is 0, I'm spending $0. When X is 1, I'm spending $2. When X is 2, I'm spending $4. When X is 3, I'm spending $6. And last one, when X is 4, I'm spending $8. Well, I could have just used this graph for the last one up here. Same relationship. 1 and 2, 2 and 4, 3, 6, 4 and 8. So I could have used that graph. The unit rate is represented by $2 a pack. Represent the relationship using a table and equation. So my Y equals KX is my equation. When Y is $2, this point right here, there's my constant of proportionality. My Y equals, when my cost is $2, it's $2 per pack. That's my constant of proportionality. It's going up by 2. So my constant is 2. So Y equals 2X. Just put in your constant of proportionality into the equation. Y equals 2X. Say they gave you different letters. Say they said number of packs, they called it P, and they said cost was C. Then you would say, oh, okay, cost equals $2 per pack. C equals 2P. So they may give you different variables on the graph, but this did say Y and X, which is why I wrote Y equals 2X. But you would have to read the graph carefully to get the correct variables in the equation there. So there's the equation, there's the table from the graph. Sally has a recipe that needs 3/4 of a teaspoon of butter for every 2 cups of milk. If Sally increases the amount of milk to 3 cups, how many teaspoons of butter are needed? So I have a couple ways that I could do this. I could set it up proportionally and do it. So for instance, 3/4 of a cup of butter for, this is butter, this is milk, for every 2 cups of milk would be equivalent to, now if it's 3 cups of milk, how much butter? So I could do it that way, and I could do a proportion. So 2x equals 3 times 3/4. So 2x equals 9/4. Divide by 2, divide by 2. When we divide fractions, we multiply by the multiplicative inverse. The multiplicative inverse of 2 over 1 is 1 over 2. So my answer would be 9/8. You would need 9/8 of a, how much teaspoons? 9/8 of a teaspoon, not cup. 9/8 of a teaspoon of butter. I could set it up doing a proportion. I could use my constant of proportionality idea that my Y is my 3/4. My X is 2 cups. I have 2 variables. Make teaspoons of butter the line, because obviously the butter depends on the milk. So, and divide this and find that 3/4 divided by 2. Okay, well that would be 3/4 times 1/2 which would be 3/8. So my constant of proportionality, y equals 3/8 x. I could use an equation and solve this. So now instead of having, since y is my butter and x is my milk, put in the 3 into this equation. Y equals 3/8 times my new milk, 3. Well, 3 times 3/8 times 3 would be 9/8. So you could use the constant of proportionality idea and solve this. I really like the proportion way of solving it. That's how I would do it. But either way, you're still going to get that it's 9/8 teaspoon of butter. To increase the milk to 3 cups, you would need an increase to 9/8 of a teaspoon. This is a ratio idea. I do not have to reduce that to 1 1/8. You can if you want to, but 9/8 is perfectly fine.